All right, so we have 6.2/6.3 square root function attributes and transformations. As far as attributes go, we've learned the parent functions before, right? So we've gone over our parent functions and what they are and what they look like and what the main values are. But for square root function, remember it's the inverse of a quadratic function that has a restricted domain, okay? So the restricted domain, that is that x has to be greater than or equal to 0, right? And so x has to be greater than or equal to 0, and that's because underneath the square root, you cannot have a negative, right? So under square root, it's no negatives. That's what that 0 is telling us, okay? So it starts at 0, and when you're taking the square root, our key points that we use are our smallest perfect squares, okay? Our smallest perfect squares are 1, 4, and 9. Agreed? And that's because 1 is 1 squared, 4 is 2 squared, 9 is 3 squared. So if you look over here on our table, we have our x and y intercept at 0, 0. We have the square root of 4 is 2. That's what this means, square root of 4. We have the square root of 9 right here. And I forgot to mark off the square root of 1. And that's how we get those values. Okay. Does the parent function attributes look familiar? Yes. Okay. So playing on that are transformations. So the graph of any square root function is a transformation of the graph of the square root parent function. So we're moving this guy. So this is the head of the family tree, and everyone else branches off from there. Okay. Remember, if we're trying to go vertical, that means we're going up or down. So our vertical translation is the square root of x plus d. So if there's a number being added, if d is greater than 0, meaning if d is positive, we're going to go up. If d is less than 0, meaning d is negative, we're going to go down, right? Remember here on horizontal transformation, our x's are liars, right? X's lie. That's why they're x's. Okay. Your x's lie. So even though it looks like it's a minus c, it's actually a positive c. So when c is greater than 0, meaning when c is technically positive, it's the absolute value of it, it's going to go to the right. When our c is negative, it's going to go to the left. Now x is a liar, so it's actually going to look the opposite. Our vertical stretch and compression, that is our variable on the outside of our radicand. So on the outside of our radicand, that's our variable right here, a. If a is greater than 1, that's a vertical stretch. If the absolute value of a is less than 1, that is a vertical compression. And if a is 0, which means if a is negative, it's a reflection in the x-axis. Okay. Horizontal stretch and compression. There's a variable on the inside, b. And key thing to remember here is when you're reading b, it needs to be b parentheses x. And sometimes you have to divide the c in order to find the b, to find their actual c. That's where they'll come from, okay? But if b is greater than 1, it's a horizontal shrink. If b is less than 1, it's a horizontal stretch. And if b is negative, that's what less than 0 means, then it's a reflection in the y-axis. So reflection in x-axis means that I have here's my original. My reflection in the y-axis is going to look like that. Because I'm changing the values of the y's. Here, if it's a reflection, in the x-axis, in the y-axis, I'm like this is my original, and would be the reflection because you're changing the values of your x's. When it's put all together, the transformation function is f of x equals a radicand b x minus c plus d. Capiche? All right. So our first example here is analyzing the domain and range. So we're going to go over graphing from using the parent function values. So if I have the square root of x minus 1, so we have f of x. I didn't mean to put f of x first. I apologize. I just needed x. We have x. We have f of x equals the square root of x minus 1. And then we're going to know what our y is. So our parent function values with 0, 1, 3, 0, 1, 4, and 9. So if I plug this in, I have the square root of 0 minus 1. What does that give me? Negative 1. I have 1, square root of 1 minus 1. What does that give me? Gives me 0, right? I have the square root of 4 minus 1. That gives me. And I have the square root of 9 minus 1, and that gives me 2. So when I'm graphing this, I'm going to make a little graph. And I'm plotting 0, negative 1. So I have 0, negative 1, 1, 0, 4, 1, and 9, 2. I don't know if I have enough room to do 9, 2. 1, 2, 3, 4, 5, 6, 7, 8. I needed to go over one more. I'll go a little off. And there is my graph. Easy enough. So I use the parent function to make the graph. The domain here. So the domain, we're going to write it in inequality and then review set notation. The domain starts at x. So x has to be greater than or equal to, it starts at 0, which means my graph is from 0 to infinity, right? My range, what is my lowest y value? Perfect, negative 1. So in interval notation, it will be from negative 1 to infinity. How do we feel? Easy enough? All right, I would like for you to try. But this time we're going to analyze the x and y intercept. So we're going to pause and try. All right. So your graph should have looked something like this. And this time I wanted you to identify your intercept. So your x and y intercept. So always, you can't say that your x and y intercept are going to always be the same. The only time they're the same is if they're at the origin. So for here, we have our x-intercept. And our x-intercept actually ended up being at 9, 0. And we have our y-intercept. And our y-intercept ended up being at 0, negative 3. How do we do? Doable? All right. Now we're going to analyze the maximum and minimum. So when you're analyzing the maximum and minimum on an interval, which we've done before, you are actually just looking at where it's going and how it's shaped. So if I have this graph, f of x equals 2 minus square root of x, because the parent function is either forever increasing or forever decreasing. Does that make sense? My max and min depend on my in values. So all I have to do is find the values of 1 and 6. So when I'm looking for my max and min, all I have to do is find the values of 1 and 6, the interval, the ends of the interval. So we have f of x equals 2 minus the square root of x. And we're looking for their y values. So we have 2 minus the square root of 1, and we have 2 minus the square root of 6. Okay, these values are not going to be exact. So when it's not perfect squares, such as the square root of 6, we do have to utilize a calculator. But for the first one, it's pretty easy. 2 minus 1 is going to give us 1, right? So we're going to analyze 2 minus the square root of 6. And to do that, we plug it into our calculator. And so the square root of 6 is approximately 2 and 4,500. So we have 2 minus 2 and 4,500. And that leaves me with approximately negative 0.45. So literally, you're just stating which one is your maximum and which is your minimum. This is my max value on the interval, and this is my min value on the interval. How do you feel about finding the max and min on an interval for square root function? Easy peasy? All right, cool. Okay. So now we're going to talk about, instead of having to always create the table and creating the graph, we can just use the table to describe transformation, okay? And so here, and then we are able to state the domain and range from there. We have y equals 2 square root of x. And because we have y equals 2 square root of x, that means we have our a value. So we know that a equals 2, right? And 2 is what tells us whether we are a vertical stretch or a vertical compression, right? A tells us that. So with the 2, what type of transformation took place here? Stretch. This is a vertical stretch by 2. Okay. So what vertical stretch, they affect our y values. So our y values are affected. So when we're thinking about our parent function, our x's aren't changing. Our x's are going to be fine. So the parent function x's that we have are 0, 1, 4, and 9. Agreed? However, our y values are changing. And because we are stretching those y values, we are doubling them. So we're going to have to multiply each y value of our parent function by 2. So our parent function values are currently 0, 1, 2, and 3. But we're going to multiply each one of them by 2 to find what they would be after the stretch. So we end up with 0, we end up with 2, we end up with 4, and we end up with 6. So from here, I can have a good idea of what my graph is doing. It's going like that, right? So I can give the generalized domain and the range of it. So the domain and the range, did the domain and range of did the domain of the parent function change? No, it's still x is greater than or equal to 0. Did the range of the parent function change? No. My y-intercept was not affected, was it? It's still at 0, 0. So it's still y is greater than or equal to 0. Did my intercepts change? I'm still at 0, 0. It's my x and my y-intercept. Okay. All right, so here again, we have only an A. Our A equals -1, 4. So if our A is -1, 4, a couple things are happening here. The negative lets us know what? There we go. It's a reflection in the x-axis. Okay, which means it's reflecting over the x-axis. Does that make sense? Okay, what is the other transformation? It's a vertical compression. Good job. So it's a vertical compression by 1, 4. So again, keeping that in mind, when it's only the A only affects which variable? The Y. My X's are gonna, I'm sorry. I pressed too many buttons. My X's are not gonna be affected. 0, 1, 4. I don't feel like doing 9. But to each Y value, I am multiplying it by -1, 4. So we have 0 times -1, 4. We have 1 times -1, 4. We have 4 times -1, 4. So my new Y values are 0, -1, 4, and -1. So in my mind, I can see that my graph, instead of going like this, it's now going like this. Did my domain change? No, my domain did not change. X is still greater than or equal to 0. Did my range change? Yes, my range did. My range is now Y is less than or equal to 0. And my intercepts are still the same. How do we feel about vertical stretch and compression? Okay, and again, vertical stretch and compression affects which variable? What variable do we affect? The Y. All right, here we have square root of x plus 2. And so this is my D variable. So we know that D equals +2. And what does D tell me? It's a translation up or down, right? So this tells me I went up 2. Agree? Because it's a +2. And just like A, D affects your Y. So just like A, D affects your Y. So my X's aren't going to be affected, only my Y's. So 0, 1, 4 are going to stay 0, 1, 4. But to each Y value of the parent function, I'm adding 2. So 0 plus 2, 1 plus 2, 2 plus 2. And so now I have 2, 3, and 4. So when I think about what the picture looks like, or what the graph looks like, I'm now here doing this, right? So what is the domain of this function? Did it change? Nope, because I didn't make any changes to my x's. What is the range of this function? Did it change? Yeah, it changed, right? What is my range now? Perfect. Y is now greater than or equal to 2. And did my intercepts change? Yeah, they did. I no longer have an x-intercept, but I have a y-intercept. And where is that at? 0, comma 2. Still okay? All right. Does it change anything different, really? Does the process change because we have d equals -3? No, just the location of the graph. So now we know we're going down 3, but our x's are staying the same, 0, 1, and 4. And our y's are now losing 3. We're subtracting 3. So we have 0 minus 3. We have 1 minus 3. We have 2 minus 3. That gives us -3, -2, -1. So that we can see where our new x-intercept is. We're going to do 9. And that gives us 3 minus 3, which equals 0. So now in our mind, our graph should be starting down here and working its way up, right? Pretend that's more of a curve than you see. Did my domain change? Nope. Did my range change? My range did. What is my range now? Perfect. Y is greater than or equal to -3. And now what do I have as intercepts? What's my x-intercept? Remember, x is when y is 0. So looking at my table, when is y 0? 9. And then my y-intercept is when x is 0. So we're at 0, comma, -3. So A and D affect my y. Are we cool with that? All right. Now we're on the inside. So the variable that we're working with now, this is our C variable, okay? So we have C equals, and it looks like a -3, but it's actually a +3 because our x is a liar, okay? So because it's the absolute value here is 3, we know that we are going to go right. So we're shifting our whole graph right 3 units. Because I'm going left and right, now I'm affecting my x values, right? I'm affecting the x values because I'm going left and right. I'm no longer vertically doing anything. This is a horizontal translation. So to each x value, in order to move right, I'm going to have to add 3. Does that make sense? So to each x value, I'm adding 3, and I am not doing anything to my y's because is there an A or D present? No. So I have 0 plus 3. I have 1 plus 3. I have 2 plus 3. And I have, not 2, I'm sorry, that's supposed to be a 4. And you get it. And my y's for my parent function are still the same, 0, 1, and 2. So that means that my graph has shifted over here to 3 and then continues to increase. Did my domain change now? Yeah, where does my graph start at now? At 3. So x has to be greater than or equal to 3. Did we change anything about our y values? No. So our y is still greater than or equal to 0. And this time we have an x-intercept, but no y. And so our x-intercept is at, comma, 0. Easy enough? So here, C, our x's are a liar, is actually -2, which means we want to move to the left 2. If I want to move my x values to the left, that means I am subtracting them. So we have x minus 2. So to every x value of the parent function, I'm subtracting 2, but the y's are changed. So we have 0 minus 2. We have 1 minus 2. We have 4 minus 2. So our new homes are at -2, -1, and +2. So when I think about the graph, it now starts over here. And we go across. Okay, so the domain here, my x moved, so x has to be greater than or equal to -2. My range is unchanged, so y is still greater than or equal to 0. My y-intercept is pretty easy. My y-intercept is at -2, 0. My x-intercept, I'm going to do a little finagling with. I know that your x-intercept is when x equals 0, right? Not when x equals 0. I wrote it in the wrong spot. My y-intercept. My bad, guys. My x-intercept is easy. It's when y equals 0, and we know when y equals 0. My y-intercept is when x equals 0, so we're just going to have to plug in 0. So if I plug in 0 to this, I have 0 plus 2. And what does that give me? The square root of 2, right? So my y-intercept is at 0, comma, the square root of 2. That's its exact location. Okay? Now we're down to our b variable. So we have our b variable, and our b is our horizontal compression or our stretch. So for b, here we have b equals 5. What does it mean if b equals 5? It's a horizontal compression. We have a horizontal compression by 5. Since we're compressing something, we're dividing it. And so even though it looks like multiplication, remember how we said our x's are liars? They're liars. We're actually dividing each x value by 5. So it doesn't look very pretty, and we're just going to quickly kind of do it. So we have our x's, and we're dividing each one by 5. And then our y's are unchanged. So we have 0 divided by 5. We have 1 divided by 5. And we have 4 divided by 5. They don't get very pretty. They're not very pretty. I'm not going to lie. Our y's are unchanged. Our y's are 0, 1, and 2. So we have 0. I'm going to write it as a decimal. We have 2/10, and we have 8/10. Okay, so keeping this in mind, our domain is unchanged, right? It still starts where? Still starts at 0. Our range is unchanged. Still starts at 0 and goes on forever. And our x and y intercept are unchanged. Our intercept is at 0, 0. And we got all that information from reading the table, right? Still increasing from left to right. Okay, this time our b value equals -1/2. Look at you. So this time it's a horizontal stretch and a reflection. And we have a reflection in the y-axis. So now to each x, remember it's opposite. So even though it looks like I'm dividing by -2, I'm actually going to be multiplying each x value by -2. And my y's are unchanged. So we have 0 times -2, we have 1 times -2, and we have 4 times -2. Gives me 0, gives me -2, gives me -8. And we're still at 0, 1, and 2. So this time, looking at my x values, instead of heading to the right, I'm heading to the left, right? So all of my x values are now negative, so my domain is changed. My domain is now x's that are less than or equal to 0, 0, -2, -8, and it will just continue. However, my y's are unchanged, so my range is still greater than or equal to 0. And my intercepts are unchanged, they're still at 0, 0. All right, when we put this all together, this is what one could potentially look like. So if I just want you to more than likely explain the attributes, but notice how on the inside it's 2x plus 2. This has to be factored in order for you to know what your b and your c are. So this would have to be transformed to y equals 3 square root of 2x plus 1 minus 4. So to get from here to here, we had to factor, right? We had to factor out the 2. And in its factored form, I know what everything is, right? I know that A equals 3, B equals 2, C equals -1, and D equals -4. And each one of these has a role. So A equals 3 lets me know that this is a vertical stretch. Agreed? B equals 2 lets me know that this is a horizontal compression. C equals -1 lets me know that this is a left. I'm going to move left. And D equals -4 lets me know that the graph was shifted down. Do we see how we took the whole transformation and broke it down? Are you comfortable being able to do that? Okay, that's the main thing that I want you to be able to do when it's all put together, is being able to say what each aspect is going to do to the graph. And then just remembering who affects what. So your A and your D affect your Y. Your B and your C affect your X. So I know that to each Y value, I'm multiplying by 3 and subtracting 4. Agreed? To each X value, I'm dividing by 2 and subtracting 1. Because that's their roles that they would play. But main thing, main goal, main objective is being able to tell me all of them. Do you feel confident in doing that? Okay, cool. Last one, just making sure you're comfortable with factoring transformations. So again, here, reiterating what that meant was here, if I have the square root of 9x minus 36, before I can describe the transformation, I need to factor what's underneath the radical. And so that leaves me with y equals, factoring out 9, x minus 4. Now that I've done that, now I can describe the transformation. I have a b value that equals 9. I have a c value that equals 4. So I have a horizontal compression. And I'm going to go 4 to the right. And because of that 4 to the right, that means my domain now starts at 4. Were there any changes to my y values? There was no change to my y value, so my y is still greater than or equal to 0. Okay? All right, so your due now tomorrow will be you answering these or all, one or two of the exit tickets, okay? Have a great day.